Okay. So, good evening, everyone. And today we'll start discussion of week six classes. So we're gonna be solving some questions where the topic has been covered in this week, and and these questions will be helpful to solve the assignments of this week. So first, we're gonna write the summary, like what are the topics that has been covered in this week. So the first topic that has been covered is the properties of beta and gamma function. Second is applications of double and triple integral. And third topic is vector differentiation. Vector differentiation. Okay, so now we'll start solving some questions from this topic, and we'll see how to solve this type of questions. Okay, now this is the first question. This is from the vector differentiation and like gradient and potential function and so on. So the question is given like this. Uh, let f from R3 to R be defined by f of x, y, z equals to cos x plus 2 e to the power y square by 2 plus z cube. Okay. Find the maximum rate of change of f at the point p at 5 by 4, 0 and 1. So this is the given point where we have to find the maximum rate of change of f. And so now we're going to do the solution. Okay. So to find the maximum rate of change, so the direction we have to consider is just the gradient of the function, correct? So if you just take the direction of the gradient of the function, that will give the maximum rate of change, and then you take just the modulus, and this is going to be the maximum value. Okay, so here gradient of f is uh, so this is the direction. in which uh, the rate of change of f is maximum. And for for negative, I mean for minimum rate of change, it will be just negative of gradient of f. Okay, and the corresponding maximum value is this. So just norm of gradient of f at p. Okay, so this is the maximum value. Okay, so here the gradient operator is defined like this. This is a vector function. So this is defined like uh, del x of I cap plus del y of j cap plus del z of k cap. Okay, so then gradient of f is gonna be del f del x I cap plus del f del y j cap plus del f del z k cap. So now we have to just find out the partial derivative of f with respect to x, y, and z. Then we are done. Correct. So f is given like this: f of x y z equals to cos x plus 2 e to the power y square by 2 plus z cube. So del f del x is just the derivative of f with respect to x, putting all other or treating all other variables as a constant. So in this case, del f del x will be minus of sin x. Similarly, del f del y is gonna be 2 e to the power y square by 2 into y, because derivative of y square by 2 will be just y. So this is simply 2y e to the power y square by 2, and del f del z is gonna be 3z square. Okay, so our gradient of f at an arbitrary point xyz is just minus sin x I cap plus 2y e to the power y square by 2 j cap plus 3z square k cap. Okay, so yeah, so this is our gradient. So now the point is given as pi by 401. So we'll just replace xyz by pi by 4 0 and 1. So gradient of f at pi by 4 0 and 1 is just minus of sine pi by 4 into I cap plus 2 times 0 into e to the power 0 by 2 0 square by 2 j cap plus 3 into 1 square k cap. So this is gonna be minus 1 by root 2 I cap plus 3 k cap, right? Now this is the direction, or we can say that this is the uh, direction of maximum rate of change of f at p. Okay, max rate of change in f at p. So this is the direction. Okay, and now the maximum value will be just the modulus of or the norm of the gradient of f at p, which is pi by 4, 0, and 1. So this is going to be minus 1 by root 2 square plus 3 square. So this is 1 by 2 plus 9, and this is around square root of 19 by 2, which is just uh, 3.08. So this is approximately. Okay. So this is the answer. So I hope this is clear. And if you have any questions, you can ask me at any time. Otherwise, you can ask me in the next class. Okay. So if this question is clear, then we're gonna move on to the next question, which is gonna be question number 2. Okay. Okay. So find out the mass of the area bounded by the parabolas uh, so this is y square equals to 3 minus x, and y square equals to 3 minus 3x. Okay. And rho xy equals to y square. Also, find out the center of gravity. Or the center of mass. Okay. Okay. So let me read the question again. So first, we have to find out the mass of the area bounded by the parabola y square equals to 3 minus x and y square equals to 3 minus 3x. Then we have to find out the center of gravity, that is the pair x bar comma y bar, which has been taught in the class. I mean, in the week classes. And here the density function is given by rho xy equals to y square. So this is just mass per unit area. Okay. So now we know that if so let R be any region, then the formula for finding the mass is given by m equals to double integration over r rho xy d of a. Okay. So here d of a is either dx dy or dy dx. Okay. And center of gravity x bar comma y bar is given by, so this x bar is gonna be 1 by m double integration over r x rho xy dA, And similarly, y bar is 1 by m double integration over r y rho xy dx. Okay, so this is the formula for finding the center of gravity. But before that, we have to find out the mass of the region R. Okay, so first we're gonna draw the parabolas and try to see the both x-intercept and y-intercept and try to draw the region, because to do the double indication we have to see what is the region R, right? So first we're gonna find out this m, and then we're gonna calculate both x bar and y bar. Okay, so yeah, so first let us write the first parabola given by y square equals to 3 minus x. So so try to see that if you put x equals to 0, so this will imply y square equals to 3, or in other words y is plus minus root 3. Now this is actually y square equals to 4ax type where a is less than 0. So that means this is a parabola where the face will be on the negative of the x-axis. Okay, so now if you just put y equals to 0, so this will imply x is 3. Okay, so now from this point, from these points, we can get an idea that how to draw the parabola. So this is going to be something like this. Okay, so yeah, so this is the point 3 comma 0. This is somewhere 0 comma root 3, and this is 0 comma minus root 3. So this will be our parabola. Okay, and so let us just remove this one. So this is 0 comma root 3, and this is 0 comma minus of root 3. Okay, okay, so now we're going to draw the next parabola, which is y square equals to 3 minus 3x. Okay, so if you just put x equals to 0, then we can see that y square is 3, and this is implying y is plus minus root 3, correct? And if you just put y equals to 0, so this is implying x is 1. Okay, and this is also y square equals to 4ax type parabola where a is strictly less than 0. Okay, so now this is going to be the graph of this parabola. So the first point x is 1 and y is plus minus 3. So this is going to be somewhere here. So yeah, so this will be something like this: 1 0 0 root 3 and 0 minus of root 3. Okay, So now we can draw the whole region R as follows. Okay, so this point is 3 comma 0, and this point is 1 comma 0. This is 0 comma root 3. This is 0 comma minus or root 3, and this one is y square equals to 3 minus x, and this one is sorry, 3 minus 3x, and this one is y square equals to 3 minus x. Okay, so this is the region. So this is the region. Okay, so now we'll find out m. So the formula for m was double integration over r rho xy dA. So our m is gonna be like this. So double integration over r. So rho xy was y square. So this will be y square dx dy. So now we can take a strip like this. Okay. So here x is our so here x is for the first curve x is y square minus sorry 3 minus y square, and and for the second one our x is 3 minus y square divided by 3. Okay, so this limit is gonna be from 3 minus y square to 3 minus sorry 3 minus y square by 3 to 3 minus y square dx dy, and the limit of y is varying from minus of root 3 to root 3. So this is going to be from minus of root 3 to root 3. Okay, so now we have to calculate this double integration, correct? So this is going to be from minus of root 3 to root 3. Now since there is no x here involved, so this will be just simply xy square, and 3 minus y square by 3 to 3 minus y square dy. So now this is just from minus of square root of 3 to square root of 3, and then y square times 3 minus y square minus of 3 minus y square divided by 3 dy. Okay, so this is from minus of square root of 3 to square root of 3 y square, and this is 2 by 3 into 3 minus y square dy. Okay, so this is 2 by 3 minus of square root of 3 to square root of 3 y square times, or simply 3y square minus y to the power 4 dy. Okay, so now the region was symmetric for the case of y, so we can just take from and then the inside function is also even, so we can take 2 outside, so that is 4 by 3 0 to root 3 3y square minus y to the power 4 dy. Okay, No, this is a simple integration. So this is going to be y cube minus y to the power 5 by 5, 0 to root 3. And this is just 4 by 3 root 3 whole cube minus root 3 whole 5 to the power 5. I mean root 3 to the power 5 divided by 5. And this is going to be 4 by 3, 3 root 3. So now root 3 to the power 5 is root 3 times root 3 into root 3 into root 3 into root 3. So this is going to be 3 root 3. Okay. So, sorry, this is going to be 9 root 3. So this is just 4 by 3. This is going to be 6 root 3 divided by 5. So this is 8 root 3 divided by 5. Okay. So m is given by 8 root 3 divided by 5. Okay. So this is our m. So now we have to just calculate the coordinate of the center, which is x bar and y bar. Now we know the formula of x bar. So this was like this. X bar will be 1 by m double integration over r x rho xy dx dy. So this is gonna be 5 divided by 8 root 3. This is double integration over r xy square dx dy. Okay. So now just like previously, we know the upper limit and lower limit of both x and y. So this is going to be from y equals to minus or root 3 to root 3, and this is 3 minus y square by 3 to 3 minus y square xy square dx dy. Okay, so this is going to be 5 divided by 8 root 3. This is minus of root 3 to root 3, and y square will be outside, x square by 2, and this is 3 minus y square by 3 to 3 minus y square, and this is going to be dy. Okay, so this is 5 divided by 8 root 3 minus of root 3 to root 3 y square times so 2 will go outside, so this is going to be 16, and then 3 minus y square whole square minus 3 minus y square by 3 whole square dy. Okay, so this is gonna be uh, 5 by uh, 5 by 16 root 3 uh, minus of root 3 to root 3 y square. So now this is 3 minus y square by 9, and if you take common of 3 minus y square, it is gonna be 1 minus 1 by 9, which is 8 by 9. So this is gonna be 8 by 9 into 3 minus y square dy. So this is 40 divided by This 40 divided by 9 times 16 root 3 minus of root 3 to root 3 and y square times 3 minus y square. So now the inside function is even. We can write it like this. 40 times 2 divided by 9 into 16 root 3. This is 0 to root 3. And then 3y square minus y to the power 4 dy. Okay. So this is going to be okay. So this is 40 by 72 root 3, 0 to root 3, or maybe we can cancel out a little bit. So this is going to be 8 and this is going to be 5. So 5 by 9 root 3, 0 to root 3, and this is going to be whole square. So y square times 3 minus y square whole square dy. Okay. So this is y square times 9 minus 6y square plus y to the power 4 dy. So 5 divided by 9 root 3, 0 to root 3, 9y square minus 6y to the power 4 plus y to the power 6 dy. So this is 5 divided by 9 root 3. This is 9 y cubed by 3 minus 6y to the power 5 by 5 plus y to the power 7 divided by 7. And this is from 0 to root 3. So 5 divided by 9 root 3, 3 into root 3 cube minus 6 times root 3 to the power 5 divided by 5 plus root 3 to the power 7 divided by 7. Okay. So this is going to be 5 divided by 9 root 3. So this will be again 9 root 3 and root 3 to the power 5 is 9 root 3. So this will be 54 root 3 by 5 plus this is going to be 27 root 3 by 7. Okay. So this is again 5 divided by 9 root 3 and this is 35 and 35 times 9 is 324. So this is going to be 315 root 3 minus of 7 into sorry, yeah, 7 into 54. So this is going to be 135 of root 3 plus sorry, this is going to be 371 root 3 plus So 5 times 27 is is 135 root 3. Okay, so this is 5 times 9 root 3 into, so 315 and 135. So this is 5 and 4 and then 371. So this is gonna be 29 plus 50. So this is gonna be 79. This is 79 divided by 35. Okay, so this is again another root 3. So this get cancelled out and this will be 7. So the answer should be 79 divided by 63. Okay, so this should be the answer for this question. So now we're going to find out the y coordinate. So this was our x coordinate. So x bar equals to 79 divided by 63. Okay, so now we're going to calculate again the y coordinate. So this is going to be our y bar, and we know the formula for y bar. So this is 5 divided by 8 root 3 minus of root 3 to root 3, 3 minus y square by 3 to 3 minus y square, and then y times rho of xy, which is y square, and then dx dy. Okay, so this is going to be again 5 divided by 8 root 3 minus of root 3 to root 3. So this is y cube times 2 by 3, 3 minus of y square dy. Okay, so this is going to be 10 divided by 24 root 3, and then minus of root 3 to root 3, 3y cube minus of y to the power 5 dy. Okay, so now since this is an odd function, so the integration from minus of square root of 3 to square root of 3 will be 0, because this is an odd function. So this answer is going to be 0. Okay, so our m is 8 root 3 by 5, and x bar y bar is 79 by 63 comma 0. Okay, is this clear? So I hope this is clear. Uh, Otherwise, we'll go to the next question. And if there is any doubt, you can always ask me either in this class or in the next class. Okay. So this is gonna be question number. So this is gonna be question number 3. So this is gonna be question number 3. Okay. If f of xyz equals to tan inverse of y by x plus tan inverse of z, then find out the directional derivative of f at p of 2, 1, minus 2 in the direction minus of I plus j plus 2 q cap. Okay. Okay. So now we're going to do the solution. Now this is, I think I have given some theory in the, I think in third week discussion or fourth week discussion, and which is like the connection between the directional derivative and the gradient at that point. So if the gradient of the function, if the function is differentiable, or at the particular point the function is differentiable, then you can easily connect the direction derivative to the dot product of the direction and the gradient at the particular point. Okay, so this is given like this. Uh, so the directional derivative of f at p in the direction u is given by p u f at p equals to gradient of f at p dot u. Okay, when f is differentiable. Okay, and here u is given by uh, minus of I plus j plus 2k cap. Okay, so first we're gonna change this to a unit vector. So here u is a unit vector. Okay, so this is a unit vector. So unit vector means norm of u is 1. Okay, so to do so, first we're gonna find out the norm of u. So norm of u is square root of 1 square plus 1 square plus 2 square, so which is square root of 6. Then our unit vector, or the new unit vector u, will be minus 1 by root 6 of I. So you just divide this norm of u to the all the coordinate of the vector u cap. Okay, plus 1 by square root of 6 j cap plus 2 divided by square root of 6 k cap. Okay, so now we have to find out the gradient of f at the point P, and then you can just do the dot product using this formula. Okay, and then we can easily find out the directional derivative in the direction u, in the direction u of unit vector, and at the point P. So for that reason, first we're going to find out the partial derivative with respect to x of f, and this is going to be del x of tan inverse of y by x plus tan inverse of z, right? Now since z is a it's not a function of x and y, it's just a variable. So the derivative of the second part will be 0, and the derivative of first part is going to be 1 divided by 1 plus y by x square into del x of y by x. This is going to be uh, x square divided by x square plus y square, and this is minus y by x square. So just minus y divided by x square plus y square. Okay, so this is our del f del x, and del f del y is uh, 1 by 1 plus y by x whole square into 1 by x. Okay, because the derivative of with respect to y of the function y by x will be just 1 by x. So this is x square divided by x square plus y square into 1 by x, which is same as x divided by x square plus y square. Okay, and del f del z is just 1 by 1 plus z square, because derivative of tan inverse z is 1 by 1 plus z square. Okay, so our uh, gradient of f at the point xyz is given by minus y divided by x square plus y square I cap plus x divided by x square plus y square j cap plus 1 by 1 plus z square k cap. Okay, now we have to just evaluate this gradient at the given point 2 1 minus 2. So gradient of f at 2 1 minus 2 is just minus of 1 divided by 6 I cap plus 2 by 6 j cap plus 1 by 5 k cap, right? So this is just minus 1 by 6 I cap plus 1 by 3 j cap plus 1 by 5 k cap. So now our directional derivative of f in the direction u and at the point p is just given by dot product of the gradient at the point p and the unit vector u. So this is just this is gonna be 5, not 6. Sorry. So this will be minus 1 divided by 5 I cap plus 2 divided by 5 j cap plus 1 by 5 k cap. So this is minus 1 by 5 I cap plus 2 by 5 j cap plus 1 by 5 k cap dot product of minus of pi plus j plus 2k divided by square root of 6. So this is just 1 by, so this is the dot product. So this will be 1 divided by 5 root square root of 6 plus 2 divided by 5 square root of 6 plus 2 divided by 5 square root of 6. So this is 5 divided by 5 square root of 6, which is just 1 divided by square root of 6. And this should be the answer of this question. Okay. So now we're going to go on to the next question, which is question number 4. Okay. Find out the value of the triple integration over t uh, root x root y root z dx dy dz where the region t is given by the region bounded by x plus y plus z equals to 1 and the coordinate planes in the first octant, that is x, y, z, and x, y, and z are equals to 0. Coordinate planes in the first octant. So that is x greater equals to 0, y greater equals to 0, and z greater equals to 0. Okay, so now this is just an application of the Dirichlet integral, which has been taught uh, in this week lectures. Now, Dirichlet integral is given like this. Integrals. So the triple integration over the region B, x to the power L minus 1, y to the power m minus 1, z to the power n minus 1, dx dy dz is gamma of L, gamma of m, and gamma of n divided by gamma of L plus m plus n plus 1. Okay, where L, m, n all are strictly positive. Okay, so and also the region V is bounded by x greater equals to 0, y greater equals to 0, z greater equals to 0, and x plus y plus z less equals to 1. Okay, so now try to see that this given integral over the region T, which is this one, uh, root x, root y, and root z dx dy dz, and this can be written as x to the power 3 by 2 minus 1, y to the power 3 by 2 minus 1, and z to the power 3 by 2 minus 1 dx dy dz, right? And using this Dirichlet integral, this is just gamma of 3 by 2 into gamma of 3 by 2. So gamma is the gamma function, gamma of 3 by 2 divided by gamma of 3 by 2 plus 3 by 2 plus 3 by 2 plus 1. Correct? So this is just gamma of 3 by 2 whole cube. So gamma of 3 by 2 whole cube divided by, so this is gonna be gamma of 11 by 2. Correct? So this is just 1 by 2 root pi, because gamma of 3 by 2 is half gamma of half, and gamma of half is root pi. So this is whole cube divided by 9 by 2, 7 by 2, 5 by 2, 3 by 2, 1 by 2, and root pi. Correct? So this is gonna be uh, pi root pi by 8 into this is 2 to the power 5. So this is gonna be 32 divided by 9 to 7 into 5 into 3 into root pi. So this got cancelled out. So this is also cancelled out. And this is going to be 4 pi divided by, uh, so this will be 945. Okay. So this should be the answer of this question. Okay. So I hope this is clear. This was not that difficult. Now let us go to the next question, which is question number 5. Okay. So evaluate the value of the integral I equals to 0 to pi by 2 tan x to the power n dx, where n is between -1 and 1. Okay. So now this can be written like this: 0 to pi by 2 sin x to the power n cos x to the power minus n. Sorry. Yeah, cos x to the power n minus of n dx. Okay. And we already know that beta of m comma l is given by 2 times integration 0 to pi by 2 uh, sin x to the power 2m minus 1 and cos x to the power 12 minus 1. So from here, we have to just find out the values of m and l, and then we can just substitute in the beta function, correct? So from the above integral, 0 to pi by 2 sin x to the power n and cos x to the power minus n dx, we can see that we can set 2m minus 1 to be n, and this will imply m equals to 1 plus n by 2. And similarly, we can also set 12 minus 1 to be minus of n, and this will imply L is 1 minus n divided by 2. Okay, so we have got our m and L both. So our integration I is given by 1 by 2 beta of m comma L, and m was n plus 1 by 2 and L was 1 minus n by 2. Okay, because here m is n plus 1 by 2 and L is 1 minus n by 2. So now we can evaluate this using the gamma function, the formula of the gamma function, which is gamma of n plus 1 by 2, gamma of 1 minus n by 2, and this is going to be gamma of n plus 1 by 2 plus 1 minus n by 2. Correct. So this is just 1 by 2 gamma of n plus 1 by 2 and gamma of 1 minus n plus 1 by 2 and divided by gamma of 1. Correct. So now using the complement formula, by applying the complement formula, so the complement formula was like this, that gamma of x into gamma of 1 minus x is just pi divided by sine of pi x. So we'll get I equals to 1 by 2 uh, pi divided by sine of pi into n plus 1 by 2. Correct. And this is going to be half divided by sorry, pi divided by 2 sine of into pi by 2 plus pi by 2. Okay, and this will be the answer of this question. Okay, or maybe you can simply write like this: uh, pi divided by 2 cos in pi by 2, and this is pi by 2 sec of in pi by 2. Now this is just a simplification, or otherwise pi divided by 2 sine n pi by 2 plus pi by 2 is also enough. Okay, so this is the answer. In pi by 2. Okay, so I hope this is clear now. Okay. If there is any doubt, you can ask me uh, in this class, or otherwise you can ask me in the next class. Okay, so now the next question is going to be question number 6. Okay, so find out the center of gravity of a plate bounded by the curves y equals to x squared and y equals to x plus 2, whose density uh, is given by rho xy equals to 1. Okay, so now since we know the formula already to find out the center of gravity, so first we have to find out the mass of that region, and then using that double integration formula we can find out the coordinate of the center of gravity, right? So before that, let us try to draw the region. Draw the region in which we're gonna perform the second or the double integration. Okay. So yeah. So first, the parabola is y equals to x square. So this will be an upward parabola. So it's like this. So this is y equals to x square, and another straight line is given by y equals to x plus 2. This is implying x minus y equals to 2, or x by 2 minus y by 2 is 1. So the intercepting points are 2 comma 0 and 0 comma minus 2, right? Okay, so this will be somewhere 2 comma 0 and sorry, this will be minus 2. So minus of 2 plus of 2. minus 2 and this is plus 2. So this will be 0, 2, and this is somewhere 0, 2, and this is somewhere minus 2 comma 0. Okay, so this is our straight line. Okay, so this is minus of 2 comma 0. Okay, and this point is gonna be so since this line is uh, x equals to 2, so I'll be 4, so this will be 2 comma 4. Okay, and we have to perform the integration here. Okay, so now first we're going to write the formula for finding the center of mass and then the coordinates of the center of gravity. Okay, so m is given by uh, now before that we have to find out this point. Now since y is x plus 2 and y equals to x square, so we can just put the value of y, which will be x plus 2, and this will imply x square minus x minus 2 is 0, and this will imply x minus 2 into uh, x plus 1 is 0, and this will imply x equals to 2 comma minus 1. So this point is gonna be uh, minus 1 comma 1. Okay, so our m is given by y from minus 1 to 1, sorry, x from minus 1 to 2, and we're gonna take a strip like this. Okay, so this will be from x squared to sorry y minus 2 to x plus 2 to x square. So this is just y equals to x square to x plus 2. Okay, and this is gonna be dy dx. So from minus 1 to 2, x x plus 2 minus x square dx. Correct. So this will be x square by 2 plus 2x minus x cube by 3 minus 1 to 2. So just put the values. This is 4 by 2 and then plus 4 minus 8 by 3 and then negative of 1 by 2 and then negative negative plus, this is positive, and then negative negative positive and then again negative, so this will be minus 1 by 3. Okay, this is going to be 2 plus 4, this is minus 9 by 3 plus 2 minus 1 by 2, so this is 4 and 4 8 minus 3 minus 1 by 2, so this is 5 minus 1 by 2, so it should be 9 by 2. Okay. So now the formula for x is given by this x bar equals to 1 by m. So it will be 2 by 9. Similarly, minus 1 to 2 and x squared to x plus 2 and x times rho dy dx. So here rho is 1, correct? So this is dy dx. This is going to be 2 divided by 9 minus 1 to 2. And similarly, this will be x times x plus 2 minus x squared dx. And this is just 2 by 9 minus 1 to 2 x squared plus 2x minus x cube dx. So this will be 2 by 9 and x cube by 3 plus x squared minus x to the 4 by 4 minus 1 to 2. And if you just calculate all this value, so the answer will be 1 by 2. Okay. Now similarly, if you calculate y bar, which is 2 by 9 minus 1 to 2 x squared to x plus 2 x plus 2 y dy dx, and this is going to be 8 by 5. Okay. So m is 9 by 2 and x bar y bar is just 1 by 2 comma 8 by 5. Okay. So this should be the answer of this question. Okay. So now we're going to go to the next question. So which is question number 7. Evaluate the our indication over r x to the power 12 minus 1 y to the power 2m minus 1 dx dy where the r region is given by x greater equals to 0, y greater equals to 0, and x square plus y square less equals to c square. Okay. Okay. So this is also an application of the Dirichlet integral. So first we're gonna change into the form, exact form of the Dirichlet integral, and then we'll try to evaluate this integral, right? And for that reason, we're gonna take capital X to be x by c whole square, and y to be y by c whole square. Okay. So this is implying now since x is positive, so x is c square root of x, and y is also c square root of y, because both small x and small y are positive, that is they are lying on the in the first octant, right? So from here dx equals to c divided by 2 root x, and dy equals to c divided by 2 root y, and there will be another dx also. Okay, so now we can substitute these values, uh, this x and capital tx to y, all of this in the actual integral. So the our integration over r, x to the power 12 minus 1, y to the power 2m minus 1, dx dy, and this is going to be over the new region r prime. So x is c root x, so c capital square root of x to the power 12 minus 1, c square root of capital Y to the power 12 minus 1, and dx is c divided by 2 root x dx, and dy is c divided by 2 root y dy. So this will be c square divided by 4 root xy dx dy, correct? Where the new region r prime is just x greater equals to 0, y greater equals to 0, and x plus y is less equals to 1, correct? So this is gonna be mm, c to the power 12 plus 2m divided by 4. This is integration from 0 to 1, 0 to 1 minus x, and this is gonna be x to the power l minus 1, uh, y to the power m minus 1 dy dx. Okay, so this will be c to the power 12 plus 2m divided by 4, integration 0 to 1. This is going to be x to the power l minus 1, y to the power m by m, 0 to 1 minus x dx. Okay, so this is c to the power 12 plus 2m divided by 4, integration 0 to 1, x to the power l minus 1, 1 minus x to the power m divided by m. So this is dx, right? And this is also same as c to the power 12 plus 2m divided by 4m, integration 0 to 1, x to the power l minus 1, 1 minus x to the power m plus 1 minus 1 d of x. Now using this Dirichlet identical formula, this is same as c to the power 12 plus 2m by 4 beta of l comma m plus 1, correct? Which is same as c to the power 12 plus 2m divided by 4 gamma of l gamma of m plus 1 divided by gamma of l plus m plus 1 plus 1, correct? So this is same as c to the power 12 plus 2m divided by 4 gamma of l gamma of m plus 1 divided by gamma of L plus m plus 2. Okay. Okay. So so this was the answer of the question number 7. And now we're gonna go to the next question, which is question number 8. Okay. And it is given like this. Find out the magnitude of the directional derivative of phi of xy equals to x divided by x square plus y square at 0, 2 along a line making an angle 30 degree with x-axis, and a line making an angle 30 degree with the y-axis. Okay, so yeah, now we're gonna do the solution. Okay, so first we're gonna find out the derivative of phi with respect to both x and y, and then we're gonna calculate the gradient, and then you can just substitute the point 0, 2, and then you can find out the directional derivative using that dot product of the gradient at the point 0, 2 and the direction, correct? Which is line making an angle 30 degree, and then the line making an angle 30 degree with the x-axis and y-axis. Okay, so first del phi del x will be, so this is gonna be x square plus y square whole square, x square plus y square into 1 minus x times 2x. So this is gonna be y square minus x square uh, divided by x square plus y square whole square, correct? And then del phi del y, this is also gonna be uh, x square plus y square whole square. So this is negative of x times 2y. So this is minus of 2xy divided by x square plus y square whole square. Okay. So our gradient of phi at x comma y is just y square minus x square divided by x square plus y square I cap uh, minus of 2xy divided by x square plus y square whole square into j cap. Okay. So gradient of phi at 0 comma 2. So this is gonna be 4 divided by 16 I cap plus 0 j cap. So this is just 4 divided by 16 I cap. Okay. So now in the first case, they have given the direction US, a line U. So a line which is making an angle 30° with the positive x-axis, correct? So this angle is 30°. So U is gonna be cos 30 I cap plus plus sin 30 j cap, right? Now cos 30° is just root 3 by 2 I cap, and sin 30 is 1 by 2 j cap. Okay, so du, so du of phi at 0 comma 2. So this is gonna be 4 by 16 into uh, root 3 by 2. So this will be root 3 by root 3 by 8. Okay. Now again, so they are saying that it's making an angle with the y-axis of 30°, correct? So this is our y, this is x. So this is like this. Now if this angle is 30°, this angle will be 60°, right? So in this case, our u is gonna be cos 60 I cap plus sin 60 j cap, correct? So this is gonna be 1 by 2 I plus root 3 by 2 j, correct? And then du phi at 0 comma 2, this is gonna be 1 by 2 into 1 by 4 j. I mean 1 by 4. Because 4 by 16 is just 1 by 4. So this is just 1 by 8. Okay. So this should be the answer. So now we're gonna go to the next question, which is question number 9. Okay. So evaluate the integral xyz x square plus y square plus z square dx dy dz, where the region V is given by x greater equals to 0, y greater equals to 0, z greater equals to 0, and x square plus y square plus z square less equals to a square. Okay. So now there are two ways to solve this integration. So first is the traditional way, by using change of variables, that is change it to a polar coordinate and then try to solve it. And the another approach is the dirichlet integral. So we're gonna solve this integration using both the approaches. So first we're gonna see the traditional way. So this is approach number one. So this is approach number one. Okay. So for that reason, to do the change of variable in polar coordinate, uh, we're gonna take x to be r cos theta sine phi, y to be r sine theta sine phi, and z to be r cos phi. Okay. So now we can see that x square plus y square plus z square is r square, and 0 is equals to theta is equals to pi by 2, and 0 is equals to phi is equals to pi by 2, because the region is in the first octant. So both theta and phi will vary from 0 to pi by 2 only. Correct. Now we have to calculate the Jacobian, which is j of xyz divided by r theta phi, which is nothing but the determinant of this matrix del x del r del x del theta del x del phi. Similarly, del y del r del y del theta and del y del phi, and again del z del r del z del theta and del z del phi, right? So now del x del r is gonna be cos theta sin phi, and del x del theta will be minus of r sin theta sin phi, and del x del phi will be r cos theta cos phi, correct? Similarly, del y del r will be sin theta sin phi, and del y del theta will be r cos theta sin phi, and del y del phi will be r sin theta cos phi, and del z del r will be cos phi, del z del theta will be 0, and del z del phi will be minus r of sin phi. Okay, so this determinant is gonna be minus of r square sine of phi. Oh, okay, thank you. So now using, so actually I lost my connection, that's why. So my internet is disturbing right now, and I'm so sorry for that. So now our integration. So this was our question, that evaluate the integration, triple integration of x, y, z, x square plus y square plus z square into dx dy dz, where the region is given by x greater equals to 0, y greater equals to 0, and z greater equals to 0, and x square plus y square plus z square is less equals to a square. Now I am solving this question using two approach. First is the conventional approach, and second is the gamma function approach, right? So I'll be using the gamma function to evaluate the integration. So now here the Jacobian is minus of r square of sin phi. Now this is very straightforward. So now our integration, triple integration v x y z x square plus y square plus z square vx vy dz, and this is gonna be changing to from integration phi equals to 0 to pi by 2, theta equals to 0 to pi by 2, and r will be from varying from 0 to a, because remember x square plus y square plus z square was less equals to a, so the radius is gonna be r equals to 0 to r equals to a. Okay, so now this is gonna be so x is r cos theta sin phi, y is r sin theta sin phi, and z is r cos phi. So you have to substitute all these x, y, z here, and if you do so, you will get something like this: r to the power 7. Sorry, this is 0 to a. So this will be r to the power 5 cos theta sin theta sin square of phi cos phi, uh, then the Jacobian, which is xyz divided by r theta phi, and then dr d theta and d phi. Okay, and we already know the Jacobian is nothing but r square of sin phi, right? So this is gonna be simply phi equals to 0 to pi by 2, theta equals to 0 to pi by 2, r equals to 0 to a, and then this is gonna be r to the power 7 cos theta sin theta, and then sine cube of phi cos of phi, and then dr d theta and d phi. Okay, so now since this is an integration of separable, I mean you can do the uh, I mean you can just separate the function in terms of theta, phi, and rho, and then you can do the integration separately. Okay, so this is gonna be from phi equals to 0 to pi by 2. So this will be sine q of phi cos phi d phi, and then theta equals to 0 to pi by 2. This is gonna be cos theta sin theta d theta, and r equals to 0 to a r to the power 7 dr. Okay, and this is gonna be phi equals to 0 to pi by 2 sine cube of phi cos of phi d phi, theta equals to 0 to pi by 2. Now this is r to the power 7 0 to a, so this will be a to the power 8 by 8, and then d theta, correct? So this is gonna be sorry, there is another cos theta sin theta. So this is gonna be a to the power 8 by 8, and then phi equals to 0 to pi by 2 sine cube of phi cos of phi d phi, and then we can write this inside thing as theta equals to 0 to pi by 2 1 by 2 times 2 of cos theta sin theta and d theta, correct? So this is gonna be a to the power 8 by 16 phi equals to 0 to pi by 2 sine cube of phi cos of phi d phi, and so this is just gonna be sine of 2 theta, right? So this will be negative of cos 2 theta divided by 2, and this is theta from 0 to pi by 2, correct? So this is gonna be a to the power 8 divided by 16, and then this is just sine to the power 4 phi by 4. Okay, 0 to pi by 2. So this is just basic integration. Okay, I'm not going doing all of this. This is just basic simple calculation, and if you do so, you will get a to the power 8 divided by 64. Okay, so I hope this is clear, and now I will be solving this using another approach. This is the second approach. Okay, so I'm going to write as a second approach, or approach number 2. So now what you're going to do is we're going to change this integration to a Dirichlet integral. Okay, because we know the form of a Dirichlet integral, that is a triple integration x to the power l minus 1, y to the power m minus 1, and z to the power n minus 1, dx dy dz over the region first octet, and x plus y plus z is less equals to 1. And this is just gamma l gamma m gamma n divided by gamma of l plus m plus n plus 1. Correct? So that we will be doing using the change of variable. So for that reason, I mean, we're going to just put capital X to be x by a. So we're going to take this capital X to be small x by a square, capital A y to be small y by a square, and capital Z to be small z by a square. Okay. Now since small x, y, and z all are positive, okay, so this will imply x equals to square root of x into a, y equals to square root of y into a, and z equals to square root of capital Z into a, right? So now from here we can see that g of x is 2a by sorry uh, a divided by 2 square root of x dx, dy equals to a divided by 2 root y dy, and dz equals to a divided by 2 root z dz. Correct? So now uh, our integration uh, square triple integration over v x y z into x square plus y square plus z square dx dy dz will be changed into the new into the triple integration over the new region v prime. So xyz will be square root of x y z into a cube into now x square plus y square plus z square. This is going to be a square times x plus y plus z, and then dx dy dz will be a by 2 square root of x into a divided by 2 square root of y into a divided by 2 square root of z, capital dx, capital dy, and capital dz, right? So this is and the region v prime is just x y and z get equals to 0, and capital X plus capital Y plus capital Z less equals to 1. Now this is because x square plus y square plus z square is less equals to a square. So this will imply x square x by a whole square so x by a whole square plus y by a whole square plus z by a whole square is less equals to 1. So now since x by a whole square is x, y by a whole square is y, and z by a whole square is z, capital Z. So this is less equals to 1. Okay. So our integration is changed into the triple integration over v prime, and then this square root of xyz got cancelled out. So this is going to be a cube by 8 x plus y plus z dx dy and dz. So this is a cube by 8 v prime x plus y plus z dx dy dz. So now see that by symmetry This is same as 3a cube. Sorry, this is going to be a to the power 8. 3a to the power 8 by 8. Then over v prime x of dx, dy, and dz. And this is same as 3a to the power 8 divided by 8 over v prime x to the power 2 minus 1, y to the power 1 minus 1, and z to the power 1 minus 1 dx, dy, and dz. Okay, so now by Dirichlet's integral integral formula. So this is same as 3 a to the power 8 divided by 8. This is gamma of 2, gamma of 1 into gamma of 1 divided by gamma of 2 plus 1 plus 1 plus 1, right? So this is 3 a to the power 8 divided by 8, and gamma of 2 is also 1, and gamma of 1 is also 1. So this is 1 divided by gamma of 5, which is just 3a to the power 8 divided by 8 into 1 by 24, and this is nothing but a to the power 8 divided by 64. Okay, so both by both approach we can see that our answer is a to the power 8 divided by 64. Okay, so now we're gonna go to the next question, which is question number 10. So find out the volume of the region bounded by the cylinder x square plus y square equals to 4, and the plane z plus y equals to 4 and z equals to 0. Okay, so now we're going to do the solution. So clearly from we can see that z is varying from 0 to 4 minus 1. So our triple integration is just going to be v equals to z from 0 to 4 minus y, and then y equals to negative square root of 4 minus x square to square root of 4 minus x square, and then x from sorry, so x is for v from minus 2 to 2, y is from minus square root of 4 minus x square to square root of 4 minus x square, and z is from 0 to 4 minus y. So this is gonna be dz, dy, and dx, right? So if a plane is cutting the cylinder, so this will be just the position will be just an circle of radius 2, correct? And this can be evaluated easily. So this is just minus 2 to 2 square root of minus of 4 minus x squared to 4 minus x squared, and then 4 minus of y dy dx. Okay, so now we can just put x equals to r cos theta and y equals to r sin theta. So this is gonna be changing to 0 to 2 pi, and then 0 to 2, 4 minus r sin theta. Okay, and here d theta, and there will be another r, which is the Jacobian. So this is the r. Okay, so this is just 0 to 2 pi. Okay, and this is 4 r squared by 2 minus r cube by 3 sin theta, 0 to 2, and d theta. So this is 0 to 2 pi, 8 minus 8 by 3 sin theta, d theta. So this is 8 theta minus 8 by 3 cos theta, 0 to 2 pi. So this is 16 minus 8 by 3 cos of 2 pi plus 8 by 3 cos of 0. Okay, so this is 16 of pi, not 16. So this is gonna be 16 pi minus of 8 by 3 plus of 8 by 3. So the answer should be 16 of pi. Okay, so yeah, I hope this is clear now. Now we gotta do the next question, which is question number 11. Now this is a very good question from directional derivative. So let f equals to x square y plus y square of z plus z square of x, then find the directional derivative uh, of f at the point 1 minus 1 2 in the direction of the point q equals to 306. Okay, also find the maximum directional derivative at p. Okay, so yeah, so basically almost everything is given in this question as we did earlier, except the direction. So the direction is very tricky here because we have to just find the direction and then use the formula. Then we're gonna get the answer, right? So we'll see one by one what is like how to find the direction in this case, because the direction has to be a unit vector, of course, right? So here del f del x. So first we're gonna find the gradient at the point P. correct? So here it is P. So first, let us try to find del f del x. So this is gonna be 2xy plus z square. Del f del y is also x square plus 2yz, and del f del z is y square plus 2xz. Okay, so our gradient of f at xyz is 2xy plus z square I cap plus x square plus 2yz j cap plus y square plus 2xz k cap, right? So now we have to evaluate gradient of f at p. So p is just 1 minus 1, 2. So this is gonna be minus 2 plus 4i plus this is x square. So 1 minus 2, sorry, 1 minus 4 j plus this is minus 1 plus 4k. So this is gonna be 2y minus of 3j plus of 3k, right? So this is gonna be 1 plus 4, so this will be 5k cap. Okay, so now to find the direction, first like to find the direction in the point of 306, we have to first calculate this direction PQ. Okay, so the direction PQ is gonna be Q minus P, so which is 3 minus 1, 0 plus 1, and then 6 minus 2, which is 2, 1, and 4. So now we'll calculate the magnitude of PQ. So this is square root of 4 plus 1 plus 16, which is square root of 21. And now our unit vector u cap will be PQ divided by square root of 21. I mean PQ divided by norm of PQ. And this is gonna be 2i plus j plus 4k divided by square root of 21. So now our directional derivative of f at the point P is just gradient of f at P dot u cap, right? And the gradient of f at P is 2i minus 3j plus 5k dot 2i plus j plus 4k divided by square root of 21. So this is 4 times 4 minus 3 plus 20 divided by square root of 21, right? So this is 21 divided by square root of 21, which is square root of 21. So this should be the required directional derivative. Okay. Now the maximum uh, value of directional derivative at P is gradient norm of gradient of f at P, correct? Which is just 2 square plus minus 3 whole square plus 5 square. So this is 4 plus 9 plus 25. So this is square root of 38. And this is going to happen in the direction of gradient of f, correct? So I hope this is clear. This is a very important question. So I'm going to put it 2 star. And because this type of questions have been asked in competitive exams. So yeah, I hope this is clear. And